Okay, let's talk about covalent bonds. So Lewis structure for covalent bonds, these happen in molecular compounds. We're looking at neighboring atoms sharing their electrons to make octets. Or for hydrogen, he's happy with a duet. So let's look at water and chlorine. So here's hydrogen. How many valence electrons does hydrogen have? One. And we'll put another hydrogen atom over here because it's H2O. And then I'll make oxygen red because it usually is red. So it's very Christmassy now. How many valence electrons does oxygen have? 6. So there's 2, 3, 4, 5, 6. I put them in that particular order because I'm thinking ahead to what I want to do with them, but you don't have to arrange them that way. So the octet rule tells us that atoms are going to exchange or share electrons in order to get an octet. So oxygen is asking this hydrogen, hey, give me your electron. Does hydrogen want to give up its electron? No, not really. Hydrogen's saying, hey, you've got all those electrons, give me one of yours. Oxygen doesn't want to do that either. So what do you do when two people want the same thing? Two kids want the same toy. You have to share, right? So we can share electrons and achieve our goals. So the hydrogen can share its electron with the oxygen. And so the oxygen now can count both of those electrons as belonging to itself. Think a husband and a wife, they each have, they have 2 children between them, right? It's like my husband and I have 6 children. It's actually a triple bond, but that's jumping ahead. So if you ask him, how many children do you have? He'll say 6. And if you ask me, I'll say 6. Does that mean there's 12 children in our house? Thank goodness not. There's barely room for 6. Why do we both call them ours? Because they're shared, right? They belong to both of us. So these 2 electrons now, when they become shared, the hydrogen counts both electrons as belonging to it. And the oxygen counts both of those as belonging to it. And so the hydrogen says, hey, I'm good now. I've got the 2 electrons. That's my duet. The oxygen now has 7 electrons. So it's happier, but it's not quite there. So it's going to find another hydrogen atom to share with. So here's another hydrogen atom. Hydrogen is happy to share with the oxygen because now it has a duet. And now the oxygen is all good. So this hydrogen has 2 electrons. This hydrogen has 2 electrons. And the oxygen has 8 electrons. Any questions? Things go farther when you share. Sharing is good. Okay, let's think about the chlorine. So here's a chlorine atom, and here's another chlorine atom. How many valence electrons do chlorine atoms have? 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. We're not going to get an ionic compound forming here because neither chlorine is willing to give an electron to the other. It's not like sodium chloride where the sodium's like, yeah, you can have that, it's okay, and the chlorine will take it and then you get ions. How would you decide which one of these loses the electron? They're the same. So they're going to share instead of transferring electrons. So if chlorine shares 1 electron with another chlorine atom, now they both feel like they have an octet of electrons. And this is Lewis theory explaining covalent bonds. Any questions? We have two kinds of electrons in these structures. We have the electrons that are being shared. Those are called bonding pairs. And then we have electrons that are not being shared. Those are called non-bonding electrons. So these electrons here, let's identify those. So both of these electrons, those form a bonding pair. So how many bonding pairs are in this water molecule?
One.
Well, there's one.
Oh, and that one gets
Two. Yeah. So water has two bonding pairs. We end up, with a lot of 8 electrons and pairs of electrons, and that's why the top, bottom, right, and left, north, south, east, west works. If you have 2 in each direction, then you have 8. 4 pairs is 8. The electrons that are not being shared are the non-bonding electrons. So how many non-bonding or lone pairs does oxygen have? I'm sorry, water.
4.
How many pairs, though?
Oh.
2 pairs. So this is one, and this is one. These are lone pairs. I like lone pairs because it's shorter than non-bonding. How many lone pairs in the chlorine molecule? 6. So this one has 6 lone pairs. And that's these guys. Any questions? You need to be able to look at a Lewis structure and tell how many lone pairs, how many bonding pairs. Well, sometimes sharing one electron with one other atom isn't enough to get an octet. And so we can share 2 or even 3 pairs of electrons. So let's look at oxygen. Okay, we've discussed oxygen earlier. Oxygen has 6 valence electrons. So we know that O2 exists. That's not a question. But why and how? Lewis theory says that oxygens are going to they're going to share electrons to get an octet of electrons. So if this oxygen shares 1 electron with the other oxygen, now they each have 7, right? We count this for both, 2, 4, 6, 7. 2, 4, 6, 7. So this is better, but not quite good enough. So they need to do more sharing, and so they'll share another electron. That's kind of an ugly drawing of it, but it works. This oxygen has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. Everybody's happy. 8 is great. So normally we would show that like this, with this double bond. Normally we don't draw the dots at each end of the line. We just draw the line. But we understand that that's a pair of electrons. So if you have trouble with that, go ahead and draw the dots in. I won't laugh at you. And then these are each going to have 2 lone pairs. And, it doesn't really matter exactly where you put the lone pairs. They just need to be there as pairs. So this oxygen has these 2 bonding pairs and 2 lone pairs. That's 8. And the other oxygen also has 8. So we call this a double bond because it's sharing 2 electron pairs. Any questions? Let's look at nitrogen. We know that nitrogen, N2, exists. So let's see if Lewis theory can predict what's going on here. Well, each of these has how many valence electrons? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I drew them in that particular order because I'm thinking ahead to what I want to do with them. I want to connect some dots. So in order to each get 8 valence electrons, they need to share some electrons. Now, this will help you when we're doing Lewis structures that are more complicated. If you look at the Lewis structure for the element and count the number of lone pairs, that's the number of bonds that atom, that element, is probably going to make. We saw here for oxygen that it had 2 unpaired electrons. It made 2 bonds. The nitrogen here has 3 unpaired electrons. It's going to form 3 bonds. And so we can see that they can share these electrons and these electrons and these electrons. So the shared electrons count for both. 2, 4, 6, 8. 2, 4, 6, 8. It reminds me of that, that cheer. 2, 4, 6, 8. Who do we appreciate? Nitrogen! So that's kind of ugly. So we would normally draw that as 3 lines between the nitrogens and then put the lone pairs around. Any questions? This is Dr. K and this is Mrs. K, and we have a triple bond, 6 children. Tommy, Michael, Emily, Andrew, James, and Zach. 6. I have to count them sometimes. We can use the Lewis model to predict which molecules are going to be stable. If it follows the octet rule, it's probably going to be stable. If we can't make octets for everything, it's probably not going to be stable. So we did H2O. So I'm just going to draw that one really quickly. So water we would draw like this. And the oxygen has 2 lone pairs. Each hydrogen has a duet. The oxygen has an octet. Lewis model says water's going to be stable. Sure enough, it is. Water's very stable. Thank goodness. What would happen, though, if we made H3O? Well, that would be bringing in another hydrogen, right? So here's another hydrogen, and that hydrogen is going to have 1 electron. How could we make H3O? Well, we'd have to connect this right here to share. Now, this hydrogen's happy. Is the oxygen happy? How many electrons does the oxygen have? You count the bonds, 2, 4, 6, 8, 9. This is like playing blackjack. 21 is awesome. 22 is horrible, right? You lose. 9 electrons is not good. This cannot be stable because it violates the octet rule. Well, what about H3O plus? How would we turn H3O into H3O with a positive charge? Take off an electron. Well, let's take this guy off. He seems out of place. And then when we do that, we have to indicate that this has a charge now. Otherwise, people are going to look at it and say, you didn't put enough electrons in there. Is this a happy molecule, ion? Does the oxygen have 8 electrons here? Wake up. Come on. Does it? Yes, it does. So the oxygen has 8 electrons. 2, 4, 6, 8. Each hydrogen has 2. Lewis theory says this is stable. It is. Let's do H2O2. So there's an H and an O and another O and another H. So here's oxygen with its 6 valence electrons, another oxygen with its 6, hydrogen with 1, and hydrogen with 1. Well, let's do some sharing. So hydrogen can share with that oxygen. This hydrogen can share with this oxygen. And then the oxygens can share with each other. And that gives us an octet for each of the elements, each atom. So we predict that H2O2 is stable, and it is, hydrogen peroxide. Any questions? Very quiet bunch today. So does the model work with things we observe? So covalent bonds, let's just go back here real quick. This covalent bond between hydrogen and oxygen is very directional. These electrons that are shared between hydrogen and oxygen are going to be between the hydrogen and the oxygen. So this is a force of attraction in one direction only. So when we think about covalent compounds, we've got discrete molecules where we have this bonding between the atoms in the molecule, but what holds the molecules together? In an ionic compound, what holds the whole thing together is the positive and negative charge attractions, the ionic bonds. In a molecule, you have these covalent bonds holding the atoms together, but between the molecules, you have very weak forces. We'll study those later. But those weak forces between molecules are called intermolecular because they're between molecules. Those are very weak, and so covalent compounds generally have lower melting points. Water has a low melting point. It's a liquid at room temperature, right? Many of the molecular compounds are gases at room temperature.